Slope fields. On page 332, exercise 34, a differential equation is given. The derivative of y with respect to x equals x minus 2y. The directions are to construct a slope field for the differential equation. And that simply means at each of these points are all given in the textbook. At each of these points, which here are in color, blue, red, and so on, we're going to calculate the slope. So, in other words, we're going to think of dy dx as if it was the change in y over the change in x. D delta, kind of the same thing. So, at the blue point, where x is negative 1 and y is 2, x is negative 1 and y is 2. We calculate that. We get negative 5. So what this means is at the blue point, the one up here, upper left, we're going to make a small line segment with slope negative 5. And we don't need to be perfect about this, but we do need to show that it'll be a line segment that's slanting down because the slope is negative, and it'll be rather steep because negative 5 is kind of a big number. 5 is a big slope, kind of steep. We can just do this at every point. A little bit tedious, but very easy. It's a common question on the AP exam to do exactly this, construct a slope field. So I'm at the red dot now. At the red dot, the slope, the change in y over the change in x for some line, is the red dot, the x coordinate is 0, and the y coordinate is 2. This is negative 4, so at the point 0, 2, we're going to make a line with negative slope, like the one we made there, but not as steep, because the slope is negative 4, so a little less steep. Just a little line segment like that. There's going to be little line segments with different slopes all over here. We're going to call the final result a slope field. And now at this magenta point, where x is 1 and y is 2, the slope at that point, where x is 1 and y is 2, looks like negative 3. So we'll make a line segment with slope negative 3. That means negative, downhill, but not as steep as the one we just made there. So these are getting less and less steep. Now we're at this light blue. At that point, the change in y over the change in x. It's always this, x minus 2y, that's the differential equation. At this point, x is negative 1, and y is 1. This is negative 3. That means this line will have the same slope as the one up there. So in other words, it will be parallel to that. And then we're on the point 0, 1. So I'm going to just give myself some space here. At this gray dot, 0, 1, the slope, change in y over change in x, is x, which is 0, minus 2 times y. 0 minus 2 is negative 2. This line segment would be even less steep than that one that has slope negative 3. More and more flat-ish. This green dot, the slope at that point, is x minus 2y. At that point, x is 1 and y is 1. 1 minus 2 is negative 1. So these are getting less and less steep as we go from left to right. This point on the x-axis, negative 1, 0. At that point, dy dx, delta y over delta x, equals x minus 2y. At that point, x is negative 1, and y is 0. That's equal to negative 1. So it will be the same steepness as the one just made. This is supposed to be parallel to the one up there. You don't have to be perfect. I mean, if it was slanting the other way, that would be a bad thing. Okay, so we're now at the point 0, 0. When x is 0 and y is 0, this will all be 0. So that means that this green dot, we make a horizontal line segment, because the slope there is 0, plugging in the coordinates of the point. And now we're at this light blue point on the x-axis. At that point, delta y over delta x, dy over dx is x minus 2y. At that point, x is 1 and y is 0. And this is going to be positive 1. So that means this line has to slope uphill. Line segment, I should say. And 3 more of these. This light gray point, at that point, the slope is x minus 2y. At that point, x is negative 1, and y is also negative 1. That's negative 1 plus 2, which is 1. This blue point on the y-axis. The slope, dy over dx, delta y over delta x, is x minus 2y. Here x is 0, and y is negative 1. This equals positive 2. So positive slope, more steep than that, because that was supposed to have slope positive 1. And the last red dot there, at that red point, the slope is x minus 2y. At this point, x is 1, and y is negative 1. This equals 3. That's pretty good. There's a field of slopes. It's a slope field. In class, we're going to talk about how this is used. What is the point of doing this? But right now, so we're not going to talk about that here, but this is just to see how to create a slope field. Tedious but easy. All right, so we're also going to discuss Euler's method. E-U-L-E-R. This is a method for solving differential equations when it's difficult to find the antiderivative, maybe even impossible. So Euler's method, it is pronounced Euler. Euler's method. And page 333, exercise 54. We have a differential equation. The derivative of y with respect to x equals 2x minus y. Y equals 0 when x equals 1 is called the initial condition. The directions are to use Euler's method with increments delta x equals 0.1 to approximate y. Here's the goal. Approximate y when x is 1.3. Okay, this is also kind of tedious, but really easy. Key to Euler's method is to think of the d's in the differential equations as deltas. So I'm rewriting the differential equation. I'm just using delta instead of d. And now we're going to multiply both sides of that equation by delta x. So delta y, that translates to the change in y, equals 2x minus y times delta x. And we are given delta x in the directions. So I'm going to replace this delta x with 0.1. So change in y equals 2x minus y times 0.1. This number is given in the directions. Now all we're going to do is create a table with an x column and a y column. The first x and y are given. The initial condition is when y is 0, when x is 1. We are given change x by this amount, 0.1. So if this is the first x, the next x is this x plus delta x. The next x is the x I just wrote plus delta x. The next x is the x that I just wrote plus delta x. And we're going to stop here because the goal is to approximate y when x is 1.3. So that's as far as we have to go. The differential equation is the change in y. So I'm going to bring this to the next page. Delta y equals 2x minus y times delta x. That is just the given differential equation with deltas instead of d's. So this means the change in y is 2 times the current x, that's 1, minus the current y, that's 0, times delta x, which is 0.1. So we figure that out. It's 2 minus 0, which is 2, times 0.1. That comes out to be 0.2. This is the change in y. What it means is you take the y that you're at, and this is what you add to it. But it's not the change. This is not the change in y every time. The change in x was 0.1 every time. That was given. The change in y is 2 times the current x, that's 1.1, minus the current y, that's 0.2. All of this times delta x, which is 0.1. So 2 times 1.1 minus 0.2, multiply that by 0.1, and you get 0.2. Let me just double check that. 2 times 1.1, subtract 0.2, and multiply that by 0.1. So the change in y is again 0.2, coincidence. So you take this previous y, the y where we're at, and this is how much we change it. So that's the next y, 0.4. All right, so here we go again. The change in y is, it's the differential equation. It's 2 times the current x. I'm talking about 1.2 minus y. That means the current y, 0.4. All that times delta x. That's always 0.1. So I'm going to do this. 2 times 1.2, subtract 0.4. All of that is times 0.1. We got 0.2 again. These don't usually come out the same. So this is the change in y. That's what I do to this y to get the next y. That's how much I add to it. 0.4 plus 0.2 is 0.6, and that's the answer. That answers the question. When x is 1.3, y is approximately 0.6. So we're going to do another one because I don't want you to think the change in y comes up the same every time. Number 58. Here's a differential equation. dy dx equals x minus 2y. Y equals 1 when x equals 2 is the initial condition. The change in x is negative 0.1. Approximate the value of y. This is the question. Approximate the value of y when x is 1.7. So just make these d's deltas. Delta y over delta x equals x minus 2y. So delta y equals this side of the equation, x minus 2y, times delta x. Multiply both sides by dx. That means the change in y will be the current x minus 2 times the current y times whatever delta x is, which is this negative 0.1. So we're going to make a table with x and y. We're going to change x by this amount each time. And this formula will give the change in y each time. It might not be the same number every time we change it. So the first x and y are given. X is 2 when y is 1. That's given. The change in x is given. Negative 0.1. So if this is x, starting x, the next x is this x plus this x. 3 plus negative 0.1 is 1.9. The next x is this x plus the change in x. 1.9 plus negative 0.1 is 1.8. The next x is this x plus delta x. That's 1.8 plus negative 0.1. This is as far as we have to go to answer the question, which is approximate y when x is 1.7. Change in y is, this is just the differential equation, x minus 2y times the change in x. In other words, the change in y is the current x, which is 2, minus 2 times the current y, which is 1, times the negative 0.1. So the current x is 2, the current y is 1. Let's calculate this right here. I'll get this to 2 minus 2, 0, 0 for the benefit of 0. So if I say the change in y is 0, that means the next y is 1. If you take the y and add the change in y, you get the next y. Change in y is not always going to be 0, even though in the last problem it was 0. So now I want to know the change in y to get from here to here. The change in y is right here. Current x of 1.9 minus 2 times the current y, which is the 1 reserve, all this times negative 0.1. 1.9 minus 2 times 1, and multiply that by negative 0.1. I get positive 0.01. This is what I add to this y to get the next y. y is 1, this is the change in y, so 1.01. I have one more change here to do. The change in y now is just the differential equation. The current x, which is 1.8, minus 2 times the current y, which is 1.9. All of this times delta x, which is negative 0.1. Calculate all this. 1.8 minus 2 times 1.01. And I have to multiply that by negative 0.1. This tells me delta y is 0.022. That's what I add to this y to get the next y. 1.01 plus 0.022. And the final answer is 1.032. That's what y equals approximately when x is 1.7. That was the question.